All right. I want to talk about this together. Okay. Okay. Can you tell me anything that you noticed right away in this graph up here? Did you look at it? If my zeros are 1 and 3, what's happening on the graph? My zeros are 1 and 3. What's happening on the graph?
The points are at 1 and 3. On the graph.
Where exactly?
On the x-axis.
Oh, on the x-axis. Okay. So remember, when we're finding our zeros, we're finding what we call x-intercepts. Okay. Now.
I told you.
Okay. So then, I saw that you factored this. I saw x minus 4, x plus 2. So what are our zeros? Positive 4 and negative 2. Do you notice at negative 2 and positive 4 we have x-intercepts? Okay. All right. So Eva, what did you and Emily factor this third one to? Okay. And if that's the case, where do the zeros live? Okay. So talk me through what I should do with that information. If I have zeros at negative 1 and 3, what should I do with that?
Put a point on them.
Where at?
On the x-axis.
On the x-axis, we know we hit negative 1 and 3. Okay? Now, we know this is a parabola. How do I figure out? I see some people have a vertex plotted. How do I know where the vertex is? How do I know?
For the axis of symmetry and from the calculators.
Okay, and how did you figure out the axis of symmetry?
I plugged in all of the plots until one of them did not have a counterpart.
You did too much work.
Yep.
Theo?
I just found the midpoint.
Oh, so this should be symmetric, right? Okay, so what is halfway between negative 1 and 3? Okay, so 1 is probably our axis of symmetry. Okay, so what happens when we plug x equals 1 into our function? 1 squared minus 2 times 1 minus 3. What's that?
It would be negative 4.
Ah, so 1 negative 4. Oh, look at, does that look like a nice parabola? Okay, so let's talk through what we just did there. Okay, without having to put ourselves through a lot of work, okay, if I know the two x-intercepts, how are we going to get the vertex? What do we know about the location of the vertex compared to our two x-intercepts? Okay. The x-coordinate is just in the middle. Okay, guess what, guys? That's what we're doing today. Will you get out your student journal and turn to page 267? It's on the board, dude. Okay, so this right here Okay, well, today's goal is if we have something that is an intercept form, we need to be able to graph it. So when I say intercept form, that means we are getting a quadratic that looks like this. A times x minus a number times x minus a number. Okay, so basically, we have a quadratic that's factored, okay? Like we did in that little warm-up, okay? If we have a quadratic that is factored, we can figure out where our x-intercepts are, P, Q. Then, we know exactly what Theo said. The axis of symmetry is halfway between our two x-intercepts. And boom, we can find our vertex. Okay? So honestly, this might be one of the quicker ways to... I'll take a turn. Hey. This might be one of the quicker ways to graph because getting the points are pretty straightforward. You don't have to do a lot of plugging in. Okay? So, I want you to come down here and I want you to write this down. F of x equals 1/2 times x minus 4 times x plus 2. Okay, so let's say I want to graph this, okay? The first thing we would need to do is find the zeros. Where are my zeros? Okay, at 4 and -2. Okay, now our axis of symmetry is halfway between those, okay? So I know that some of you can look at it and figure out where the middle is, but how do we mathematically find the middle?
Maybe take the bigger number minus the smaller number.
Not quite. How do I find the middle of 4 and -2? Derek? Did you have your hand up?
Yeah.
How do we do it?
I was just about to ask if I could go grab a drink.
Make a pass. How do I find the middle? Yeah, you add them up and divide by 2, okay? Now, I know a lot of us can figure out that it's at 1, okay, without having to do that. But 4 plus -2 divided by 2 gives us 1. So our axis of symmetry is at x equals 1. Okay, and from there we can figure out where our vertex is. Okay, so our vertex is at 1 comma something. How do I figure out exactly where it is? Okay, plug it in. We can come up here, f of 1. We have 1/2 times x minus 4 times x plus 2. What's 1 minus 4? What's 1 plus 2? Okay, so we have negative 3 times 1/2. So negative 9/2 is okay. Okay, go to the next page. Okay, could you find me the x-intercepts in number 2 and our axis of symmetry? Okay, so find me two things, x-intercepts and axis of symmetry. All right, Dot, what are our two x-intercepts? 2 and 3. Okay, which means our axis of symmetry is where, Emily?
2. 2.5. Oh.
The axis of symmetry, what? Okay, 2.5. 2.5, 5/2, whichever one you put is fine. Okay. Oh,
Oh, did we win?
yes, I did. Woo, they got fishes. Exactly what I needed.
What do you get?
Sorry. I don't know, a gift card of some sort. Okay, sorry. I got really excited about that. All right. I got a bingo. All right, so this is what I'm going to have you do. While I go collect my earnings, I am going to have you plot the two x-intercepts, draw in the axis of symmetry, and I'll be right back.
Why are you so close there?
All right. Where are our x-intercepts? Not everybody all at once.
-5, -1.
Thank you. Okay. So you know how I have always given you an XY chart for these? Okay. You are not going to have to worry about filling out the first and the fifth box. Okay? Your two x-intercepts are two of the 3 points that I want. We have a coordinate at negative 5, 0. We have a coordinate at negative 1, 0. Okay? Then, we have our axis of symmetry. Where does that occur? Negative 3. So you know what? That is where our vertex is, at negative 3. So then, to figure out our vertex, we're going to have to plug it back in. We have negative 3 plus 5 and negative 3 plus 1.
2.
So 2 times negative 2?
Yes.
Negative 4? Boom, we have a parabola. Isn't that great? I know you're excited, Willa. All right, you are going to graph number 4 without my assistance. There's a It was a rock that you guys drug in from 6th period. Miles, where are our 2 intercepts?
3 and 1.
Okay. So 1, 0 and 3, 0. Okay? Tell me something we know about this parabola based on its A value.
It's up. It's negative.
You mean it's upside down?
Yeah, that's what I meant.
Okay,
Like, it's
well, you
like
said
higher
up.
like the thing, middle thing.
So,
Vertex.
since this is negative, our parabola is going to be upside down.
That's what I meant.
Okay?
That's exactly
Since this is 4, what else are we going to know? It's skinny. Upside down, skinny. Okay? We know that our vertex is at 2 something. Rachel, what do we get when we plug in 2? Do we agree with 4? I agree with 4. Okay. Good. Okay. Now, just like warning you, like tomorrow I'm going to give you a worksheet. Monday you're going to get a review on your test. I just kept the XY table, the standard 5 spots for the coordinates. If I'm asking you to use the intercept method, how many spots do you need to fill? Only 3. 2 intercepts in the vertex. Don't worry about the other 2. Okay. Now, I want to come down here to number 6. If I want to use the intercept method, what are we going to have to do for this one? What are we going to have to do, Joey? We are going to have to factor it. Okay. And luckily for you, kind of gave you that preview in your warm-up. You're welcome. Okay. What multiplies to negative 15 and adds to 2?
3 and 5.
Plus 5 minus 3?
Yes.
Okay. So our intercepts are at negative 5 and 3. Which direction is this going to open? Up or down?
Up.
Ooh, we know that because our A value is
Positive.
positive. Ooh, I didn't do a very good job of that. Hold on. Okay. If this opens up, well, it doesn't matter if it opens up or not. Okay. What is halfway between negative 5 and 3?
Negative 2.
Do we agree with negative 2? We don't? Negative 5 plus 3 divided by 2.
Was it negative 2? Negative 1.
Negative 1. And if we plug in negative 1, now, here we have 2 options. You can go to the original or you can go to the intercept method. I think the intercept method, you probably can do mental math a little easier than you can when we were plugging it in. Really, in this one, it probably doesn't matter. But if we have 4, oh, do we have 4 times negative 4?
Yes.
Negative 16? You know what I'm going to do? I'm going to do negative 4, negative 8, negative 12, negative 16. Now, I don't have to count that far. Oh, good gracious, Miss Homan. Why is it wide?
Because it's an x squared. It's because
Because I counted my y's different than my x's.